Consider this language L consisting of set of strings such that x is over 0 comma 1 star and number of zeros in x is same as number of ones in x. This represents the number of zeros and this represents the number of ones. Okay. We have already seen the special cases of this, which are a power n, b power n, or 0 power n, 1 power n, or 1 power n, 0 power n, things like this. Now, this one is a larger question, meaning strings like 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 0, 0, and they are all part of this. Okay, but the thought process kind of the intuition we had in developing this CFG will be of use over here as well. The thought process that we used or the patterns that we have identified when we designed this similar pattern is true here as well. So what was our thought process? Thought process was this: when you generate a 0, the corresponding 1 should also be generated. When we generate a 1, corresponding 0 should be generated. Correct? So otherwise we will lose control over this equality. If you just generate 0 alone or 1 alone, we will lose control over the number of zeros generated or the number of ones generated. Because we want equality, every time a 0 is generated, somewhere you should generate 1. It need not be immediate, so somewhere it should be there. So let's take that thought process forward. What we will do is the following. So when I say 0s1 or 1s1, s implies this, s implies this. Now, whenever a 0 is generated, a corresponding 1 is also generated. Similarly, 1, a corresponding 0. Now, this will generate 0 power n, 1 power n if you start doing like this. And this will generate 1 power n, 0 power n. But how do we generate this mix? So look at this pattern. This pattern, you can split this as something like 1 power n, 0 power n, 1 power n, 0 power n. And something like 0, 1, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0. Suppose you have a string like this. Now this can be seen as 0 power n, 1 power n, 0 power n, 1 power n, 0 power n, 1 power n, 1 power n, 0 power n, 1 power n, 0 power n, 0 power n, 1 power n. Meaning it is of this form. That's all I am saying. Which means when you take an arbitrary string from this, one can come up with this pattern. You may find a block of 0 followed by block of 1's. Then what you do, you can see that as it is respecting this pattern. Or it may be like this. So 4 zeros followed by 2 1's and followed by another 2 1's followed by 0 0 followed by 1 1 and again this is of the form 0 power n, 1 power n, again 0 power n, 1 power n, then you may have maybe 1 0 like this. So again here it is 0 power n, 1 power n, here it is 1 power n, 1 power n. So a block of 0 followed by a block of 1's. Again, this block size alone varies. In some places it is 4, some places it is 1, some places it is 2, but certainly you have this pattern. Choose any string, you get to see this. So it is only a mix of this 1 power n, 0 power n, if you look at any arbitrary string. Fine. So you may generate 2 zeros now, and then maybe just a 1 now, and after that you may need a 0, then after that I may generate 2 1's. So something like this can happen. Now you see that this one is 0 power n, this power is 0 power n, 1 power n, then this one is 0 power n, 1 power n. So even something like this can happen. So what is this telling you? The 0 power n, 1 power n is on the extreme, and in between you get to see 0 power n, 1 power n, the sub ones. Or it could be like this. The adjacent ones, one may be 0 power n, 1 power n, the other one could be 1 power n, 0 power n. Correct? This is all possible. So now with this pattern, you get to see that you can have these two patterns adjacent to it in any form, or you may have this, and inside this you will have something like this, which means if I write S imply SS, now it will take care of this part. Okay. It could be any form, 1 power n, 0 power n, again 1 power n, 0 power n, or 0 power n followed by 1 power n. So in any form it will be taken care. And things like this, you do 0, 1 as many times you want. Then inside this you need a pattern, so choose this. Fine. Now somewhere I have to terminate, right? So I say S imply epsilon. So that's all. So we just use this, which is what I was referring to earlier. Once you know basic CFGs, when we get a question like this, which is a generalization of something that is known to us, we should try using this, we should try kind of modifying this to known CFGs. So that's precisely what we have done, which you can always do if you pay attention to a couple of sample strings and see our strings generated and look at the pattern, and accordingly you can fine tune this to get a CFG which is meeting our requirement. So that's all. Now if you want to test drive, say take S imply SS, now use this to generate 1 power n, 0 power n, and use this to generate 0 power n, 1 power n. Or S imply 0 S1, again 0 S1, and now what you do, you can have whatever you want. You can have SS followed by 1 1, and this S could be 1 power n, 0 power n. This could be again 1 power n, 0 power n. And you can apply this any number of times. Okay. And from 1 we got 2, and if you need 3, then it becomes 0 S S 1. Take this and then replace this, and take this, replace this. It's a mixed derivation. Now you substitute appropriate value for S according to the block. This could be 1 power n, 0 power n, or it could be 0 power n, 1 power n. Accordingly you can choose this and plug in. So this is precisely doing the job. Once you extract a pattern, you just observe that if you substitute this in addition to what we had before, that is doing the job. Fine. Having seen the equality part, let's look at the related one, x over 0 1 star, such that the number of zeros in x is not same as number of ones in x. So this one, you can look at it this way. This is precisely union of two languages, L1 union L2. What is L1? L1 is all those x such that number of zeros is more than number of ones. And L2 is all those x such that number of ones is more. Fine, so this is precisely what you get. Okay. Now this also tells you that if you get CFG for this and CFG for this, then this tells you that if L is union of L1 union L2, and if you have CFG for these two, then you get CFG for L. Okay. So now it tells you that union of two CFGs is also a CFG. So which means you have a push down automaton corresponding to this, you have a push down automaton corresponding to this. The union of these two is also, there exists a push down automaton corresponding to the language L1 union L2. Now it is interesting to ask other set theoretic operations such as concatenation and intersection, complement, and clean A star, something that we have seen as part of regular grammars or regular languages. We shall look at that little later, but let's pay attention to this. Let's look at the L1. Number of zeros is more than number of ones. Supposing I say A imply 0, then it satisfies this. Or I say 0A, this is OR symbol, A implies 0 or A implies 0A. So I use this and keep generating zeros, that will also satisfy this. Now the question is, how do we introduce 1? Let's look at a couple of patterns. So the simplest one is 0. The next one is 0 0 1 or 0 1 0 or 1 0 0. If you look at this, after that if you go to 2 length string is only 0 0. Correct? The moment you have 1, then we may not satisfy this, we will not satisfy this constraint. Okay, so it is 0 or 0 0, and the moment you have 1, we should have at least 2 zeros. Correct? So which means the base string with 1 will have length 3. Now this can be generalized. What am I saying? You look at 0 0, and I may have one more 0 followed by 1 1, or you may have so many zeros followed by 1 1. That's all fine. Now look at this. This becomes maybe 0 0 1 and maybe another 0 followed by this. So what is this telling us? You replace this with another pattern. That another pattern ensures if you have a 1, you have at least 2 zeros. You can expand this and you can have any number of zeros. Okay, so if you look at a string like this, something like this, some arbitrary string satisfying this. Now look at the pattern. You get to see that you have a 0 and then 1 followed by a 0, or you have 1 0 0 or 1 0 0. Fine. So something like this you get to see over here. Now how do we look at this and this? So can you associate uh, this 0 and this 1 and followed by this and this, or how do we interpret this? Okay, so one has to pay attention to a string like this, so that this pattern can be generalized to an arbitrary strings. So from this, the question is, how do we generate 4 length strings? How do we generate 5 length strings? For example, look at 4 length strings. 4 length strings, it should have more zeros. Suppose it has 2 zeros. Can we have 2 ones? No, that's not allowed. And but 3 zeros followed by 1 is allowed. And this could be like this also, 1 triple 0 or 0 1 0 0, and basically this 1 can come in any of these positions. Okay, or it could be 0 0 1 followed by 0. So 2 zeros, 1 1 is allowed. The moment you go for the next one, 4 length strings, you cannot have 2 ones. If you have 2 ones and 2 zeros, then this is violated. So it should be 3 zeros and 1s. Now you see, how do we generate from this the next pattern, which is having this. Okay. So this says 1 remains the same. You just have to pump one more 0, which you can always do using this. And similarly, from this, you may get something like 0 0 1 0 or 0 1 0 0. This tells you that you will have to replace this with another 0, meaning 0 0, or you will have to replace this with 0 0, which you can always do using this. Okay, so it clearly tells you that one can build this and generate this pattern. Now a 4 length string is generated. How do we go for a 5 length string? From this, if I want a 5 length string, how will I do it? Okay. And for a 5 length string, one can have 2 ones. For example, I can have 1 1 followed by triple 0. Supposing it is this, and how can we get following this? So let me take 1 followed by 0 0. Now can we replace this 0 with something like 1 0 0, or maybe 1 0 first followed by that 0 will be replaced by another 0 0. Okay, so this is the general idea. Now let's try formalizing this. Now I speak in terms of zeros and ones. Okay, that may not give you the correct picture. Now let's introduce non-terminals so that we get to understand how things work. So let's take this pattern forward. It says if you introduce a 1, you should have introduced at least 2 zeros, and this can come in these three forms. So then we say that A implies 1 AA or A1A or AA1. Now along with this you bring this as well. A implies 0 or 0A. Now you can see that with this you can generate any number of zeros. This property is respected. Now you have a 1. Now these two should have 1 0, at least 1 year, at least 1 year. Or you can replace this with another pattern from this. That's what we were discussing when we were discussing this example, right? And I was telling I'll replace this 0 with this, or this 1 with this, and now when you bring non-terminal you get to see the correct picture. Now you replace this with 0, this with 0, job is done. However, you want more zeros, yes, use this for this, use this for this, job is done. But you want to introduce a 1, that's where you have to be careful. So when you want to introduce a 1, that 1 can come in any of this form. It could be 1AA or A1A or AA1. Then introduce this. Remember, when you bring 1, 1, you also bring 2 places for zeros. That could be at least 1, or that could be exactly 1, or it could be a block of zeros. Or you may replace that A with another 1. Again you bring 2 places for block of zeros. So you never introduce 1 just like that. You never introduce 1 without looking at the corresponding zeros, because you should guarantee that number of zeros is at least 1 more, right? Which is why we have 2 A's. And this will ensure if a 1 is introduced, you have at least 2 zeros. For every 1, you see that at least 2 zeros are present somewhere. Now, that's all. This clearly gives you the set of strings satisfying this condition. Fine.